sure to like and subscribe right now. Yes, do it. This is Ronit from MathEx, and today we're going to be doing something a little bit special for our first video of 2022. Now, in this video, on our agenda, we're going to be learning about modular, and after that, we're going to be solving an IMO problem with said modular. Now, if you do not know what IMO is, that's okay. I'll explain it. And if you don't know what modular is, completely fine. We're going to be learning about it. But anyways, without further ado, let's get started. So, what is mod? And mod is going to be the abbreviation for modular. Now, mod is when you have two positive numbers, a and n. A modulo n, abbreviated as mod n, is the remainder of when you have a division between a by n, where a is the dividend and n is the divisor. And this modulo operation is to be distinguished from the symbol mod, which refers to modulus or divisor one is operating from. Now, if you don't get that whole load of jumbloo, it's fine. Because to simplify in a few words, when you have a division between a and n, the mod, if you have just a mod n, is just gonna result in the remainder. So, when you have two numbers, let's say, 6 and 3, the mod of that is just gonna be 0. Because when you have 6 divided by 3, there's no remainder of it. So that's what mod is in a few words. And we're going to be testing out your knowledge on it to see if you actually paid attention. So let's try. 0 mod 4. So 0 mod 4, 0 divided by 4, remainder is going to be 0. So we're going to have 1 mod 4, and 1 mod 4 is just going to see how much 4s can go into 1, and there's going to be none, so we're just going to have a remainder of 1. Then 7 mod 4. 7 divided by 4 is going to have a remainder of 3. Then 4 mod 4. 4 mod 4, 4 divided by 4 is just going to be 1. Remainder is going to be 0. So let's see if we're right here. 0, 1, 3, and 0, which is what we got when we did the problems. Meaning, if you got these, you're perfectly well as well in this. But anyways, now that we've learned about mod, we're going to be solving an IMO. Now, if you don't get what IMO is, perfectly fine. We're going to be reading over it. So, we're going to be solving an IMO. And what is the IMO? The IMO is the International Mathematical Olympiad, and it is annual math competition for students younger than 20 who have not started at university. And each year, participating countries in this IMO send at most 6 students. So, basically, the IMO is a very hard competition. And we know this because this competition is multiple levels above most other problems we do on this channel, like AIME problems, AIMCA, AIMC 10. This IMO is way above it. And we can also see because very few people take this IMO, meaning it's very special, but also very hard. But anyways, let's get into this problem. So, it says here, for A, find all positive integers n for which 2 to the n minus 1 is divisible by 7. And for B, prove that there is no positive integer n for which 2 to the n plus 1 is divisible by 7. So we can formulate some stuff from this. So we know that 2 to the n is going to be equivalent to 2, 4, and 1 mod 7. And why? It's because let's say we test out a few values. Let's have n be 3. So n be 3 is going to be 8. And 8 mod 7 is going to be 1. And let's have n be 2. So then 2, the mod's just going to be 4. Then for n being 1, it's going to be 2 mod 7. And then if it's just 0, it's just going to be 1 mod 7. So we can see here there's some repeating values, 2, 4, and 1. And if we plug in 1, 2, and 0, mod 3. And you may be wondering why we got the mod 3. It's because 1, 2, and 0, they're all values you get when you do mod 3. So we're just going to write it out as mod 3. So let's have this displayed out here so we can solve part A and part B. 2 to n is equivalent to 4, 2, 1 mod 7, only for n being 2, 1, 0 mod 3. Now, let's solve part A. So it says find all positive integers n for which 2 to the n minus 1 is divisible by 7. Now, this is easy because how have we found these numbers 2, 1, 0 mod 3? We know that n is only divisible by 3 from our statement here. And we can prove this by testing a few values. So 2 cubed, which is going to be 8 mod 7, that's just going to be 1. Then let's do 2 to the 4th to prove that it's only divisible by 3. So 16 minus 1 is going to be equal to 15. And 15 is not divisible by 7. Now, let's try another multiple of 3. 6. 2 to the 6, 64. 64 minus 1, 63 divided by 7. That works, as it's going to be equal to 9. Now, let's try just one more value that's not 3. Multiple. And let's try 5. 2 to the 5. That's going to be equal to 32. 32 minus 1, 31. 31 divided by 7, not possible. It's going to formulate a remainder. So, as you see here, we know now that n is only divisible by 3. Now, that's going to be for part A. See? Now, let's solve part B. Now, from our statement here for B, we can know that 2 to n can never be congruent to minus 1 mod 7. And you know how we got this is basically we need to get a 0 to get divisible by 7, and we can't get 2 to the n congruent to minus 1 mod 7, as minus 1 mod 7 just translate simpler when you have it positive into 6 mod 7. And this statement here, I don't see a 6 here, so 2 to the n can never be this minus 1 mod 7. So there is no possible way that n could ever be new positive. So there's no solutions for n. Yeah, so when we formulated our statement here, we never could get the 6 mod 7 or minus 1 mod 7. So we have solved both part A and part B of this problem. Now, as you can see, using some simple mod, or just I would like to say some advanced division, we could solve a very high-ranking problem, the IMO. This just goes to show how you can use simple concepts to solve such high-tier problems, and pretty easily, as we see here. Like, the IMO is a competition said to be 6 days, but we solved this maybe like less than 10 minutes. But anyways, as you can see, we've solved this problem, meaning we are now officially finished.